Hello, my dear students. Today we are going to study the chemistry of orbitals, and we will also study what are their shapes. So first we begin the discussion with the definition of orbitals. An orbital is a three-dimensional description of the most likely location of an electron around the atom. Means it's that space around the nucleus where electron is found with maximum probability. It was a problem to locate or to describe exactly where electron is found in the atom. Niels Bohr proposed the structure of the atom in which he used the word orbit. And he proposed that it's a definite path on which electron moves around the nucleus. But due to defects in Niels Bohr model, so many problems came with the position and momentum of electrons. So Schrödinger solved this problem. He gave a clear idea of the position of the electron around the nucleus, and he used the word orbital. That's why it is defined that it's a three-dimensional description where electrons are found with maximum probability. Means nucleus के बाहर वो जगह space में which is covering three dimensions where the electrons are found, यानी इलेक्ट्रॉन की 95% डेंसिटी जहाँ पर पाई जाती है, जहाँ इलेक्ट्रॉन को हम लोकेट कर सकते हैं, that is called as orbital. The next point in atomic theory and quantum mechanics, an atomic orbital is the mathematical function describing the location and wave-like behavior of an electron in any atom. And this function can be used to calculate the probability of finding any electron of an atom in a specific region around the atom's nucleus. So, the latest structure of the atom is defined as in the center over a very smaller region, the positive charge is found with neutrons, and this area is called as the nucleus. But the electron is found around the nucleus, and where it is found with maximum probability, that space is called as an orbital. Now again we begin the discussion from quantum numbers. In the previous lecture I explained you what quantum numbers are, and there are four in types. The very first quantum number is called as principal quantum numbers, and it describes the shells or the path, the energy level around the nucleus, and its number is never zero. It starts from 1, 2, 3 and onward. But the very next quantum number defines the subshell. Yes, I'm talking about azimuthal quantum number. And there are four subshells in any atom. The very first subshell, which is spherical. It is almost spherical, means the probability of finding the electron is equal in this sphere. And for this, the azimuthal quantum number is 0. But for p subshells, the azimuthal quantum number is 1. For d, the azimuthal quantum number is 2. And for f, the azimuthal quantum number is 3. Now you have to remember one more thing with it, that S subshell can accommodate only 2 electrons. But P subshells can have 6 electrons in it, and D can have 10, and F subshells can accommodate maximum 14 electrons in it. Now we go ahead and we study about magnetic quantum number. Now this time we study the orientation in space. Now we are more closer to our today's topic. As you know that the subshell P can accommodate 6 electrons, but these 6 electrons are found in 3 different x's. First, px orbital, then py orbitals and pz orbitals. As I told you in the very beginning of this lecture that orbitals are the space where electrons are found with maximum probability. So here we can see this is the area where electrons are found with maximum probability, and the shape is dumbbell. Do you remember the electron's wave function is also studied, and it seems like a stationary wave like this, and this is bulged inside because this area, this is the phase where electrons are not found. The next 2 electrons out of 6 are found here on the y-axis. So again, the magnetic quantum number is also defining its orientation. So they are on y-axis. The last 2 electrons are found on this area, and this is the pz orbitals. Next we see the d subshell. Do you remember that d subshell can accommodate 10 electrons, and there are 5 possibilities: d, y, z, d, x, y, like one of them are on x-axis, the next is on y, then d, x, z, dx square, y square, and dz square. So this is how, when we see their possible orientations, we know the L for d orbital is 2. So the possible directions: -2, -1, 0, +1, and +2. The next thing, which is the summary of today's lecture. So when we apply the whole chemistry of orbitals for a single atom of hydrogen, you know hydrogen atoms has only 1 electron. So its only electron is found in the very first region around the nucleus, and that is in 1s. Suppose we talk about another element in which the electrons are found in 2 shells. Maybe I'm talking about lithium. Okay, now lithium has 3 electrons, and out of these 3, 2 electrons are found in the very first space around the nucleus, which is called as 1s. Now the third electron is found in the second s orbital belonging to the second shell or second energy level. Now when we see the shapes of the s orbitals, the very first cloud of electron, or the very first space where the density is found, is in a sphere, and the next sphere belonging to the next shell. So this is how we write its configuration: 2s1. Now summarizing the sublevel P. The P subshell has 6 electrons, and these 6 electrons are found in 3 orientations like this. So subshell P has 3 orbitals in it. Similarly, subshell D has 5 orbitals shown in the blue, and subshell F has 7 orbitals like this. I hope that this lecture is enough to help you in making the very clear understanding of orbitals. I'm leaving you with the hope that after watching this video to learn this topic will be very easy. Thank you. God bless you.